All right, welcome to Unit 4, Lesson 6. This is the homework help for taking sides. So we're going to start with number 1 on the ready. Let's graph each set of equations and find the point where they intersect. So we actually have done this just recently in Lesson 5. We ended up doing this, right? This was like the last step. So it's what we're going to start with on Lesson 6. So graph each set of equations. We will graph this equation in green and the second equation in purple. So let's get our green equation graphed first. So starting off, we are in y equals mx plus b form, where that plus 4 at the end, that is our y-intercept. So we are going to put that on the graph first, right? There's a little point for our 4. And then from there, we are going to go down 1 to the right 3, because that's our slope, right? The negative says if we go up or down. And then the 3 is how far to the right. So down 1 over 3. Down 1 over 3, that gives us a point here. Down 1 over 3 gives a point there. Down 1 over 3, we can't go over more, but we could also go up 1 and to the left 3. So up 1 to the left 3 is here. Up 1 to the left 3 is here, it looks like. And up 1 to the left 3 is right there. All right, so those are our points. Let's get those graphed. And that looks okay to me. It's not perfect, but that's fine. And now the purple, here we go. So that's our first equation graphed. And our second equation is negative x plus 2. All right, so we have a slope of negative 1, and it intersects at positive 2. So that's our intersection point right there. It's kind of hard to see because we're zoomed out, but we will zoom in a little bit, just so we can see more clearly. There we go. So a slope of negative 1, right, because it's just negative x. So that would mean we would go like over 1, down 1. Oh, we got to be drawing in purple. Over 1, down 1, over 1, down 1, right, and so on. So these are our points, but it doesn't seem like any of those are actually approaching the green line. So let's go the other way, right? If we go the other way, right, it looks like, aha, we do intersect, but let's finish drawing this line first. There we go. So we do end up crossing over, and it seems like the crossover point, it's not perfectly drawn, but that's okay. It seems like our crossover point was right here. That's where we have a point from each line on the same sort of grid mark. And that appears to be at negative 3, comma 5. All right, so our point, we're going to scroll down here a little bit. Our point of intersection, which is what it's asking for here, is x is negative 3, so we put that first, negative 3, and then it was 5 on the y-axis, so negative 3, comma 5. So that is the point of intersection. Now we're going to move on to the next one. We're not doing 2 for right now. We'll leave that one. We're skipping 3 as well, so we're right to 4. Here we go. All right. This should be zoomed in enough. Once again, we will do green for the first. Right, we'll do this one in green, and the second one in purple. And all right, let's see. Y equals negative x minus 2. So our intercept, our y-intercept, is negative 2. Right, so that's going to be right here. Oh, doesn't always like when I draw points, but that's okay. So that point, and then we have a slope of negative 1, right? So that means we go over 1, down 1. Over 1, down 1, over 1, down 1, and so on. We'll just add all of these points. All right, and we'll go the other way. We can also go to the left 1 and up 1. Excellent. All right, that's all of the points on this graph. We'll now give a little bit of a trace through it, and that should be pretty good. So that's our first line graphed. And now the second line, we look at, it is y equals 2x minus 8. So we're looking back up at the top. Y equals 2x minus 8. So our intersect, right, our y-intercept is negative 8. Right, so that's down there. I knew it was going to pop up that little window. So it's down there, and it has a slope of 2, which means we're going over 1 up 2. Right, so we're going to go to there, to here, right, and we'll keep going a little bit further. There we go, and it seems like we're going to go all the way down to this point here. That seems pretty good. And our intersection point now is right there, which appears to be 2 and negative 4. So our point is 2 in the x direction, and negative 4 in the y direction. So 2, comma, negative 4. All right, here we go. We're on to the set. Here are the instructions, but the problems will actually start on the next page. So each inequality below on the next page was solved incorrectly. All right, so they're telling us right off the bat it's incorrect. And you know what? Since it's incorrect, let's do it in red. Incorrectly, right? It feels powerful to like correct some bad word, right? To mark incorrections or to mark kind of errors in red seems accurate. So it was solved incorrectly. Identify the mistakes that were made, then correct the mistakes and provide the correct solution. All right, so then, and we'll do this in a different color. Maybe we'll do this in green and red, right? Identify the mistakes that were made. Actually, maybe we want to identify the mistakes. All right, we're going to mix this one up a little bit. We're actually going to do, we'll do like this nice, like kind of orangey kind of color in between the two. So we'll say, we'll identify the mistakes. Oh no, we'll do that one in red, right? That seems thematic, right? Identify the mistakes, right, that were made, and then correct the mistakes. There we go. Correcting the mistakes, we will do in, we'll do that in red as well. We'll correct the mistakes in red, but we will do the correct solution, provide the correct solution. We'll do that in green. So, right, anything that's wrong, we'll do in red, and then we'll do the right steps in green. So let's move on. All right, let's see what happened, what went wrong, what went right, and all that. All right, so we're starting with number 5. All right, here's our inequality. Right, 3x minus 2 is less than or equal to 2x plus 5. All right, so it looks like first they just copied that down, right? So it's like if they gave us that problem, the first step was just to copy down the problem, sort of in our own handwriting, but it's the somebody who's typing it, so their handwriting is exactly the same as it was written. So it is giving us just a copy, right? So this is just copied. That's fine, right? That's just copied. All right, so I would say that, yep, we can add 2 to both sides. If we add 2 to the left side, it should become 3x, so this is good, right? That part's good. But if we add 2 to 2x plus 5, we should have 2x plus 7. So this part is wrong, right? We should have 2x plus 7, right? This should be 2x plus 7. So it looks like they added the 2 to the x's instead of adding it to the numbers. So that's not quite right. And then what did they do? Then it looks like they subtracted 5 from both sides, which you can do. Yep, you could then subtract 5 from both sides. That would be the correct next step. Assuming they did that right? We would take away 5 from both sides. That's fine. Subtract 3x from both sides. That's fine. So we would get negative 5 is less than or equal to x. All right, so it seems like this is the only mistake in the problem. So let's solve it the right way. So their first step is where they went wrong. So 3x minus 2 is less than or equal to 2x plus 5. 2x plus 5. So that's what we got. I like their first step of adding 2 to both sides, but it's sort of where they went wrong, right? So if we add 2 to both sides, we should have 3x is less than or equal to, and then we should have 2x plus 7. So that's where they went wrong. Now we can take away 2x from both sides, minus 2x, minus 2x. And then we should be left with x. Oh, didn't quite get that one. Should be left with just x is less than or equal to 7. Right? So that should be our solution. So they were close. I mean, they had the right step. They just, careless error where you added 2 and you decided to add it to the number attached to the x instead of the number by itself. So a close one, but we did catch that error. 6 and 7 we are not going to correct. We'll leave those undone for right now. 8, here we go. All right, let's start off with our red, right? It looks like these 2 lines are exactly the same, so that is just copied. That's correct. All right. Take away 6. So it looks like they're taking the 6 away from here, which should leave us with 5x. That's correct. And if we have negative 54 minus 7x, and we take away 6, this side is also correct. And then if we have adding 7x to both sides, that would get rid of that plus 7x is getting rid of this. So we do have minus 60 left on this side and then 12x on this side. That's correct. And then if we have, if we divide both sides by 12, that'll leave just x, right? So the 12 is attacking this. So that's correct. And negative 60 divided by 12 is negative 5. So that side's correct. So if we just work down and the numbers are correct on both sides, right? We just said like this is a sound way of solving it. So if the numbers are all correct, but the problem states that there's something incorrect, the only thing left to look at, right, is this, is this column in the middle, right? If we look down the column, we have to make sure that we are preserving the inequality when we need to and flipping it when we need to. So we start out with less than, right? So this is less than, which is correct, right? The copy is correct. But then on this step, right? On this step right here, we flipped the inequality, but all we did was subtract by 6, right? So minus 6 does not flip an inequality. Does not flip an inequality. Inequality. So that's a hard one to find because all of the numbers, like we're trained to look for the numbers in math, and all of the numbers are perfect, right? The only thing that happened was that this inequality got flipped and then it stayed flipped, right? Then it stayed flipped and it stayed flipped. So once we get down to the end, the only thing that's wrong is this inequality is facing the wrong way, right? That's the only thing. That's the only thing. So to solve this the right way, I guess, is just to, right, it's to take all of their work, right, but it's to move this portion over here and say negative 5, and we just have to flip the inequality back the right way. Negative 5 is less than x, and that would be correct, right? Because we said that all of the numbers, right, all the numbers are fine, right? All the numbers are good. The direction of the inequality was the only problem. Oh. direction of inequality was the only error. And some of you are wondering, right, maybe it's like, oh, well, what happens? There we go, lights are back on. You might be wondering what happens if, like, on, a test, a quiz, some sort of a quick check. Like, what if we do this? What if we flip the inequality and that's the only thing that's wrong? The answer is this is pretty close to perfect, right? This is pretty good. So I would not be like, don't be upset. If like this is a very small error, right? All the numbers are good, right? So a lot of the hard work was done correctly, and it's like, I mean, this is just one very very small error that, I mean, even in this practice problem, it's hard to catch, but a good thing to keep an eye out for going forward. Right? Make sure your inequalities are facing the right way. All right, on to number 10. Solve each inequality. Oh, it's not letting me scroll. There we go. Solve each inequality. All right, let's do number 10 in one color and number 11 in another. So solving inequalities, we're not going to work in red anymore. That was a one-time thing. No more red. That's just for like the sort of grading type thing. All right, so solve the inequality. First thing I want to do is expand this side. I want to expand that. All right, so we're going to copy everything else down. 4 minus 6x is less than or equal to. Let's expand it so that's 2 is getting distributed to the 2x and to the 3. So we should have 4x. Oh, didn't quite work out. 4x plus 6. All right, now we have negative 6x's on one side, so let's actually move the x's over. So we're going to add 6x to both sides, plus 6x plus 6x. And this should be 4 is less than or equal to 10x plus 6. And then we're going to take away 6 from both sides. Yeah, we can do that. Minus 6. Oh, that's not a minus 6. Here we go. Minus 6 minus 6. So we get negative 2 is less than or equal to 10x. And finally, we will carry this up and over. Minus 2 less than or equal to 10x. Right, we will divide both sides by 10. Oh, divide both sides by 10, which leaves negative, we could write this as negative 2/10. That's fine. Negative 2/10 equals, no, not equals, not equals at all, is less than or equal to x. And right on cue, lights went off again. 1 second. There we go. Maybe it's just a way to keep everybody engaged, is to have the lights go off automatically. We'll make it seem like it's intentional. All right, so number 11 now. We'll do this one in green. We said we were going to switch the colors. 6 times 4x plus 3 is greater than or equal to 2 times x minus 2. All right, let's expand both sides, actually. Right, we're going to expand both sides. Expand both sides, which means we're doing that on both sides. So on the left side, we're going to have 24x plus 18 is greater than or equal to 2x minus 4. All right, that's what we get. And let's make the x's go to the left and the numbers go to the right. Let's do that. So x is to the left, minus 2x from both sides. 24x minus 2x should be 22x. We still have that plus 18 is greater than or equal to greater than or equal to, the 2x has gone away, so we just have minus 4, negative 4. And then we have minus, we can subtract 18 from both sides. Minus 18 from both sides. So we get 22x is greater than or equal to negative 22. Oh, well, that's very nice that it works out like that. Last step is we will divide both sides by 22. And we get x is greater than or equal to negative 1. There we go. That is our inequality totally solved. All right, it looks like we're doing one more inequality solution. Here you go. So let's do that. No expansion necessary. We are just going to solve, and we'll do this one. We had just been doing them in green, so we'll do one in purple now. We already only have the x's on this side and the number on this side. Right, so we only have x's on the right side, so we're just going to keep the x's on the right side. So let's add 6 to both sides. Plus 6 plus 6. All right, we get 30 is greater than negative 5x. Now we divide both sides by negative 5. Divide both sides by negative 5. What do we have to do when we divide both sides by negative 5? Yep, we do need to flip the inequality when we multiply or divide by a negative. Right, so now we have negative 6 is what's left here, but we flip the inequality, and now we have x over here, right? And that is the solution to this inequality. All right, the last portion. Solve each literal equation for the indicated variable. All right, so it seems like they're going to give us an equation with some meaning, and then we have to solve the equation. So we can do that. We'll do the first one in green, second one in purple, third one in green. So we'll alternate. All right, so we'll do green on this one, purple on this one, and green on this one. And so there's no confusion. That was a squiggle, not a 3. There we go. Not a 3. It's a squiggle. All right, so green on the first one. The equation y equals mx plus b is the equation of a line. Solve the equation for b. Okay, so y equals mx plus b. Let's start right here with it. Y equals mx plus b. All right, we want to solve the equation for b. Well, that means that we just need to move the mx to the other side. So let's subtract mx from both sides. Right? We should have y minus mx equals b. Perfect. That was very straightforward. All right, that was easy. I hope the next one is just as easy as that. All right, 15. Oh boy. The equation for the circumference c of a circle with radius r is c equals 2 pi. Oh boy. So this is, if anybody is not familiar, right, this is the logo, or the symbol, I should say. It's not really a logo. It's a symbol for pi. There we go. Solve the equation for the radius r. All right. So our equation is C equals 2 pi r. 2 pi r. And we want to solve for the radius r. Okay, well, we need to get r alone. So this is 2 times pi times r. And pi is just a number that we write as a symbol. It's a number that is, it's called an irrational number, which means it never repeats itself. So we can't write it very easily as like a decimal or a fraction even. So we just write it as the symbol, but it's a number. So imagine pi as being very close to 3. So this would be like 2 times very close to 3 times r is equal to c. So we can actually divide both sides by this quantity 2 pi, right? So if we divide both sides by 2 pi, right, divided by 2 pi, we should be left with c divided by 2 pi is equal to just r, right? Because the 2 pi and the 2 pi will cancel, right? The fractions will cancel the 2 pi, and we should be left with just r. So that is our solution there. All right, last one, 16, we're going back to green. The equation for the area of a circle A based on diameter D, oh, the diameter of the circle, okay. So fun fact, diameter is equal to 2r, but that's fine, we're using D here, is area equals pi times d squared divided by 4. Solve the equation to isolate the diameter D. Okay. So we're going to start by rewriting our equation. A equals pi times d squared over 4. Okay. This one's going to be hard, but that's okay. First thing we're going to do is let's divide both sides by pi. All right, that's going to be the first one. Divide both sides by pi. Divide by pi. Divide by pi. That'll cancel the pi away from the right side. So we should now have a divided by pi equals d squared over 4. D squared over 4. I just said 4, but I wrote pi. That's not right. D squared over 4. Okay. Now it looks like the next thing we have to do is move that 4 to the other side. So we're going to multiply both sides by 4 times, it's going to let me draw. There you go, times 4 and times 4. So we now have 4a divided by pi. 4 times a divided by pi is equal to, and it should just be d squared. And then the last step, and this is pretty hard, like this is definitely the hardest step, is if we have d squared, the opposite, or the way to undo a square is to square root. And this goes back a couple units now, but the way to undo a square is to square root. So our last step is actually to square root both sides. Oop. There we go. Square root that side, square root this side. And what that means is we are going to end up with the square root of 4a divided by pi equals d, right? And that is the final answer for this problem. And not just for this problem, that is the answer for the final problem in Unit 4 homework help. I hope this was helpful.